Breaking news tone. Tonight, astronomers have issued a groundbreaking update on the interstellar comet 3I/Atlas. Since its discovery in July 2025, this cosmic visitor has captivated scientists and the public alike. Now, data suggests there is a 60% chance that 3I/Atlas will behave in unexpected ways, raising excitement, concern, and questions about what this object may do as it passes through our solar system. What is 3I/Atlas? 3I/Atlas is the third confirmed interstellar object to visit our solar system, following Oumuamua in 2017 and Comet Borisov in 2019. Unlike typical comets originating in our Oort cloud or Kuiper belt, 3I/Atlas comes from outside the solar system. Its hyperbolic orbit confirms it will leave our neighborhood after a brief visit. From the moment of discovery, 3I/Atlas has stood out due to its unusual mass, estimated at tens of billions of tons, its trajectory, which differs from normal comet paths, and its composition, showing an abnormally high CO2 to water ratio in its coma. These features have made it a primary focus for telescopes around the world, including the James Webb Space Telescope, JWST, Hubble, and the Neil Gehrels Swift Observatory. Trajectory and closest approach. Astronomers have carefully calculated its path through the solar system. 3I/Atlas will pass safely millions of kilometers from Earth, well beyond the Moon's orbit. Its path brings it closer to Mars and through the inner solar system before it continues outward. While no collision threat exists, its unpredictable activity could cause slight variations in its trajectory, which scientists are monitoring closely. Visibility for observers. For stargazers, the big question is whether 3I/Atlas can be seen. Naked eye visibility, unlikely. Even at closest approach, the comet remains faint. Telescope visibility, possible with mid to large-sized telescopes, especially if unexpected outgassing brightens the comet. Best conditions, dark skies far from city lights, with the comet above the horizon during nighttime hours. Professional astronomers are tracking 3I/Atlas continuously, noting brightness changes, jet activity, and possible fragmentation that could alter its visibility. James Webb's observations. JWST has provided crucial insights. Using its near-infrared instruments, Webb detected high levels of CO2 relative to water in the comet's coma. Density variations in the nucleus, suggesting an uneven internal structure. Thermal anomalies, hinting at subsurface activity or cavities. These findings show that 3I/Atlas is more complex than a standard comet and could act unpredictably as it has 60% chance of the unexpected. Recent modeling, incorporating Webb's data, indicates a 60% probability of unusual behavior. Possible scenarios include fragmentation, internal stresses could split the comet into multiple pieces. Trajectory shifts, outgassing or minor gravitational interactions could slightly alter its path. Sudden brightening, jets of gas and dust could increase visibility dramatically. 60% chance of the unexpected. Recent modeling, incorporating Webb's data, indicates a 60% probability of unusual behavior. Possible scenarios include fragmentation, internal stresses could split the comet into multiple pieces. Trajectory shifts, outgassing or minor gravitational interactions could slightly alter its path. Sudden brightening, jets of gas and dust could increase visibility dramatically. While none of these scenarios pose a direct threat to Earth, they make the comet a high-priority observational target. Mars and the inner solar system. 3I/Atlas will pass closer to Mars than Earth. Martian orbiters and telescopes may capture unique data, such as fragmentation patterns, surface composition differences, activity jets invisible from Earth. Even minor gravitational nudges could slightly change the comet's trajectory, adding to its unpredictable nature. Global scientific response. Observatories worldwide are engaged in intensive monitoring. Ground-based telescopes track motion, brightness, and outgassing. Space telescopes monitor composition and thermal behavior. Computational models simulate fragmentation or orbital changes. NASA and ESA emphasize that while 3I/Atlas is a curiosity, There is no immediate danger, but vigilance is essential. Public and scientific fascination. The public is captivated by the comet, and scientists are equally intrigued. Interstellar objects like 3I/Atlas provide a rare look into material from other star systems. Challenge existing models of comet behavior. Spark debates about unexpected phenomena, including rare possibilities of artificial structure, purely speculative. Social media buzzes with speculation, theories, and excitement about what the 60% probability truly entails. Observing 3I/Atlas in the coming weeks. The comet remains observable for months, giving both amateur and professional astronomers opportunities to study it. Key points include: monitoring for sudden brightening or fragmentation, tracking chemical composition and outgassing patterns, crowdsourced observations contributing to scientific data. This is a rare chance to study an interstellar object up close, revealing insights into the composition and dynamics of material from beyond our solar system. Implications and takeaways. 3I/Atlas is a messenger from another star system, carrying material that has never been observed directly before. Its unpredictable behavior, reflected in the 60% chance of the unexpected, makes it a scientifically invaluable and fascinating object. Even without posing a danger, it challenges our understanding of cometary physics, interstellar dynamics, and solar system modeling. It reminds humanity that the universe is dynamic, vast, and full of surprises. In conclusion, 3I/Atlas will not collide with Earth, but it remains an extraordinary natural laboratory. While naked-eye observation is unlikely, telescope users may witness its activity if outgassing or fragmentation occurs. Scientists will continue to monitor every change in its path and composition, providing real-time updates on one of the most extraordinary interstellar visitors humanity has ever seen. The universe has sent us a visitor from beyond, a 33-billion-ton enigma moving silently through our solar system, challenging our knowledge and captivating our imagination. Stay tuned for continuing coverage on 3I/Atlas, now 60% chance of the unexpected. Historical context of interstellar objects. 3I/Atlas is not only remarkable for its size and trajectory but also because it belongs to a rare class of objects known as interstellar visitors. Before Oumuamua in 2017, humanity had never confirmed an object from outside the solar system passing through our cosmic neighborhood. The discovery of 3I/Atlas represents a new chapter in astronomy, allowing scientists to study material formed around other stars, billions of light-years away. The significance is profound. Every fragment of ice, dust, and rock in 3I/Atlas carries information about the chemical composition and evolutionary history of distant planetary systems. Studying it could reveal secrets about star formation, planetary system dynamics, and even the origins of organic molecules that seed planets with the building blocks of life. Scientific speculations about its interior. Recent observations suggest that the interior of 3I/Atlas may be more complex than initially thought. The unusual CO2 dominance, coupled with density variations detected by JWST, has led scientists to propose several theories. Layered composition. The nucleus may have alternating layers of ice and denser materials, a phenomenon rarely observed in comets. Subsurface chambers. Pockets of volatile gas could exist beneath a solid crust, which might vent unpredictably as the comet warms. Fractures and cavities. These could explain sudden outgassing events, jets, or even minor fragmentation. While these possibilities are scientifically plausible, they also highlight why 3I/Atlas is considered highly unpredictable, reinforcing the 60% probability of unexpected behavior, potential interactions with planets. As 3I/Atlas passes through the inner solar system, it will approach the orbital path of Mars. Even though it will not collide, gravitational interactions could subtly alter both the comet's trajectory and the motion of nearby small bodies, such as asteroids or space debris. Such interactions are rarely observed in real time, and this is the first opportunity for astronomers to see how an interstellar object behaves when influenced by planetary gravity. The data collected could improve our understanding of orbital dynamics, not only for comets but also for asteroids, dwarf planets, and exoplanetary debris fields, observing techniques and challenges. Monitoring 3I/Atlas presents several challenges. Distance: even at closest approach, the comet remains millions of kilometers away. Brightness fluctuations: jets and outgassing can make it suddenly brighter or fainter, complicating predictions. Background interference: the comet can blend with star fields, requiring precise imaging and tracking. Professional astronomers are using a combination of infrared, ultraviolet, and visible light telescopes to monitor these factors. Amateur astronomers with moderate telescopes can also contribute by imaging the comet and reporting observations to global networks, helping refine models and predictions. Why the public is fascinated. Beyond scientific significance, 3I/Atlas has captured public imagination. The idea of an object from another star system visiting our solar system resonates deeply. Social media and news outlets have amplified discussion, ranging from serious scientific debate to speculative theories about hidden structures or alien artifacts. While the scientific consensus is that 3I/Atlas is entirely natural, its unusual composition, trajectory, and mass make it an object of mystery. Every observation, every unexpected jet or flare, adds to the narrative of this interstellar wanderer. Future missions and observations. The scientific community is exploring potential missions to further study interstellar objects like 3I/Atlas. Flyby spacecraft: proposals exist for fast missions that could intercept such objects during future interstellar passages. Enhanced telescopic monitoring: both Earth-based and space-based instruments will continue observing 3I/Atlas as it recedes from the inner solar system. Spectroscopic studies: detailed chemical analysis could reveal rare compounds, including organic molecules and complex ices. Such missions are costly and technologically challenging, but the scientific payoff could be extraordinary, revealing how other planetary systems form and evolve. The broader implications for astronomy. 3I/Atlas underscores how little we truly know about interstellar space. Observing it provides a once-in-a-lifetime opportunity to study material from outside the solar system up close. Each discovery challenges models of cometary physics, solar system formation, and interstellar travel. The comet also reminds us of the dynamic and unpredictable nature of the cosmos. While humans often view space as static and distant, 3I/Atlas is a reminder that the universe is in constant motion, with billions of objects silently traversing the galaxy, occasionally passing near our planetary neighborhood. Dramatic takeaway. The 60% chance of unexpected behavior makes 3I/Atlas a compelling story, blending science, suspense, and wonder. Even without posing a threat to Earth, it highlights the power of observation, technology, and human curiosity. In the coming weeks, astronomers will continue their careful monitoring, capturing images, analyzing data, and refining models. Every jet, flare, and movement of this interstellar visitor will be recorded, studied, and shared with the world. As we watch 3I/Atlas, we are reminded that humanity is a tiny observer in a vast, unpredictable galaxy, witnessing the rare passage of a visitor that has journeyed light years to reach us. Closing narration. To summarize, 3I/Atlas will not collide with Earth. It may be visible through telescopes, and its behavior may surprise scientists, highlighting a 60% chance of unexpected activity. James Webb, Hubble, and ground-based observatories continue to monitor the comet, providing humanity a rare opportunity to observe material from another star system firsthand. This cosmic visitor reminds us that the universe is full of surprises, and that every interstellar object carries secrets waiting to be uncovered. Stay tuned as we continue to track 3I/Atlas, the 33 billion-ton wanderer moving silently through our solar system, leaving us both awe-inspired and captivated by the unknown.